Well, good afternoon. My name is Isabelle again, still the same person, haven't changed. But we're going to change topics for a second and talk about quantum. One of the reasons we assembled this fantastic panel here is we actually are investing quite a lot at WSO2 on quantum safeness, and have already, if you're using Identity Server, the latest version, it is quantum safe. Also investing a lot in Ballerina. And we got a lot of questions from companies about this. There's a lot happening around that topic as well. So we thought it would be a good idea to talk about the topic, maybe raise some, have some more knowledge of why are we even talking about this? What's the problem? Am I even concerned by all this quantum safeness story? And for that, we have three gentlemen here who are super specialists on the topic, can explain anything you want, answer any questions, right? And this is a panel, right? So the original vocation of a panel is not that I am asking questions and those gentlemen answer, is also to answer your questions, right? So we'll start by kind of setting the stage on why are we talking about this and what's the problem. But then if you have any questions, please do not hesitate. This is your opportunity to actually do it. With this said, I'll let you introduce yourself.
Good afternoon, everyone. I'm Biraja Ghoshal. I head data and AI practice for Tata Consultancy Services. I'm also QSCATE quantum advocate, focusing on quantum machine learning.
How do? I'm Charlie Dickinson. I'm a director in Ernst & Young, and I lead the security architecture and operational technology specialization within our team. I focus on post-quantum cryptography and lots of the more technical aspects, and prior to that I was in offensive cyber in the UK government.
Hello there, my name is Thomas Matheus. I'm CTO and co-founder of Cystel. We're a Newcastle-based cybersecurity consulting firm. I mainly lead on projects. So for example, we're working on a quantum key distribution project with British Telecom, Toshiba, and HSBC to develop assurance around quantum key distributions. But then simultaneously, I look after our projects, the ones we're probably going to be talking about in terms of cryptographic risk assessment and transitioning organizations towards better post-quantum security.
All right, so let's start by defining the problem, I would say. Why are we here? Why are we talking about this? Biraja.
See, today we assume that if your data leaks, still our encryption can keep it safe, or it is stolen, still nobody can read it. But this is not going to happen once quantum computers are available, because the algorithms, like Grover's algorithms, which can really weaken the kind of symmetric cryptography almost half in complexity. Whereas if you see far more dangerous is the source algorithm, which can completely break the asymmetric cryptography like RSA algorithms or ECC algorithms, completely collapse these things. Because even if you take today, the RSA algorithm is 2048 C bits long. In classical computer, it is not possible to break it. It takes thousands of years. But once quantum computer available, say around 5,000 qubits or 7,000 qubits, it can break RSA algorithm within a minute. So basically, whatever the data you have, see, attackers can steal all your financial records, all your medical histories, or any kind of government secret information, and wait for the quantum computers ready and decrypt it. So basically, once quantum computer available, your all the cyber security aspects, all the cryptography will completely collapse. All the privacy will vanish. Any kind of transactions that we are doing online will not be trusted, and the sensitive data also will lose the identity and credibility. That's why it's right time to all as an industry to focus how we can address the post-quantum computing predominantly from the security aspects. Yeah. Thomas, into add.
Okay, you say soon. When is when?
Well, we don't know, and the answer that you provided there is absolutely true. I think what you mentioned in trust and the ability to 100% trust the existing conventional public key cryptography that we rely so heavily on, that underpins the internet and networks communication. We will lose trust in it, but it's not going to be an overnight thing. It's not going to be a quantum computer comes out, you can buy it in Currys, and now all of a sudden you can destroy any network. It'll be a long difficult process to get to the level of quantum capability that will be able to break it in under a minute, say. At the moment, the best quantum computers that we have with reasonable error checking that IBM says they have is just around 1,000 qubits, which is the unit that they measure these in. Google said in 2024 that you'd need a 1 million qubit computer to be able to break RSA 2048, and it would take it a week. And so the risk is there, it's coming, but it's about how we prepare for it and about how we balance the risk between what's coming and what we have now. And one of the things I worry about most, I'm sure all of you in enterprise technology will have gone through some change management process. No change is inherently risk-free, and so we have to balance all these things up before we decide to do anything.
I also think a necessity to kind of move towards post-quantum cryptography has to do with what we see currently in the press. So we see very large organizations being hacked quite problematically. And so that is without a quantum computer. Now, to put a different spin on what was said here, so in order to hack the most effective version of RSA, somebody put a statement saying that we would need to bring the world's ocean to a boil. So we're quite far away from that. However, we are here today because we have this idea of harvest now, decrypt later, so we can point directions in anywhere we want. Everybody is harvesting our data. Think about what happened maybe to this large automotive company. They were hacked. Surely data was stolen there. What happened if, what can we say? The R&D data was stolen for a car they wanted to launch in 2050. I'd imagine the competitive advantage you may be able to get from that. Think about any industry with a supply chain, right? And so it's not just about preventing data in terms of PII, it's also about the data, let's say, that we have developed a very sophisticated, let's say, MRI scanner. How many revolutions does my MRI scanner need to make in order to produce the best MRI scan? So that data is valuable to organizations. You wouldn't want that to be stolen, right? And so our version is that we need to start this journey now, also because when you're speaking to chief information officers, they know, yes, we've got cryptography, yeah, it's symmetric, asymmetric, but then if you're lifting the carpet a little bit, then where do we have it? What do we have exactly? It's not really known. Right?
So bouncing back on that harvest now, decrypt later thing, is there any specific industry, or why would it be more impacted as a company or an industry as another?
Well, like we said, the time that we estimate it'll take to decrypt something, even if there is this quantum computer available, whether it's a week, whether it's a minute, the capability will increase in the future. And so there's a real valuable activity that can be undertaken in trying to risk model what information it is that you're protecting. So absolutely, trade secrets that will be valuable to your competitors in 5 years, in 10 years, those things absolutely need protecting, because you're going to be, if it's going to be worth somebody running a state-of-the-art quantum computer in 2032 for 1 year to break the encryption on a file, and they're going to spend hundreds of thousands, millions of pounds on the energy required to do that, that's something that will need protecting as a high priority. But a lot of the data that we worry about day to day at protecting with encryption now, credit card information, financial information, that isn't relevant in 10 years' time. You'll have a new credit card by that point. To me, the people who should be most worried are those organizations with secrets that need to be secret in 40 years' time, in 30 years' time, 20 years' time. My time in the government, in the military, messages being sent between ambassadors and the Foreign Office, those will be of interest to adversaries, to other nation states in 100 years' time, 150 years' time. And so things like that, things that will be eternally secret, will be the things that need to be protected the most urgently and might be worth some initial friction getting things set up or wrapping in multiple forms of protection to keep it secret.
We were talking about data integrity, right? So all of us are using data, all of us are using AI to make decisions, right? But what if somebody got access to this data, which is a revenue stream for us based on how we analyze that data, and how we then make decisions. That could be from a financial perspective, right? Imagine if you had a quantum computer, or even without a quantum computer, if you're able to make predictions based on the data you have gathered for anything, right? If somebody got access to the data, fiddled with it, that would be an issue.
Quantum computers are not noise-free, but the architecture that is coming up is a hybrid architecture, is a quantum computers along with the classical computers. And we are already seeing some progress in terms of protein folding, like last year Nobel Prize that is given to for protein folding. They took the long time, but if you simulate it in hybrid architecture, it is a minutes of job today. That is really simulated that way. The way is a cryptography is kind of things, RS algorithms or ECC algorithms, which are really in true quantum computer evolve, it will take time. But if you go for hybrid architecture, still attackers can break it within a few hours or days time frame. So really most important in the organization for digital infrastructure we have evolved over the last 50 years, 60. So most important is that to know your assets, like cryptographic assets, what kinds of protocols are being used, how data is stored and how it is stored, what kind of security keys you are using, what kind of digital signature you are using. Most of the organizations today, they don't know exactly the kind of inventory. It is pretty sure because it is evolved over the time. And identify what are the right assets you need. That's why even instead of waiting for the true quantum computers to be available, then you start the journey, it will be too late for that. That time you will not get time to fix it, because like if you want to change the rivets where ship is sailing, and that time with the passengers, you cannot do that. You cannot stop your entire digital infrastructure and change it. So you have to have ready right now to know what are the cryptographic assets you have in the organization end to end. Not only your internal applications, but also some vendor supplied applications. And are those applications in future is going to be PQC compliant or not? That's also important. Because we cannot wait the true quantum computer to be evolved with say 10,000 bits, qubits and all. No, the hybrid architecture is sufficient enough today to do things very fast and very efficient way. That's what I'm saying. Instead of waiting for that, I think it's time for organizations to start preparing now.
So before we go any further in what should we do, I just wanted to maybe if you take a minute to explain why are quantum computers so good at cracking RSA or ECC? What makes them so powerful at doing that? Want to take that, Char?
Well, sure. It's just a fundamentally different way of operating. They rely on some really complicated mathematics called quantum mechanics. There's a quantum phenomenon that lets them consider problems in a completely different way to the serial, fast, transistor-based, regular conventional cryptography that we're used to. There was a researcher who came up with this algorithm, Shor's algorithm, that enables you to solve the fundamentally big problem that keeps the RSA algorithm, that keeps this asymmetric encryption safe, the idea of factoring large primes, and this algorithm that requires the use of a quantum computer to perform it is able to kind of weaken that and to bring it out of the exponential space where all these things happen with conventional cryptography. This will take you, yes, you can guess every single permutation of this problem, but it'll take you more time than you have in the universe, and you'll need to boil the ocean to do it. It can take it down into linear space, so you can start to parallelize it more effectively and start to look at the problem there.
Maybe an interesting way of thinking about this is if you walked into a library and then you would be able to read a book in the library sequentially, whereas a quantum computer, or if you were a quantum computer, you could read every book simultaneously. And so this idea of superposition, that a qubit can assume the position of 1 and 0 at the same time, and this idea of entanglement, that qubits are connected to each other, these two phenomena together, they actually make a quantum computer much, much faster. But the idea behind that is that we need sufficient qubits in order to do that, and we don't have that at the moment. So that's good news, but it's also bad news because it prevents us from working on ever more complex optimization problems, because quantum computing is not just being used to hack stuff, it's also being used to optimize things, right? So we can make better financial predictions if we had a sufficiently developed quantum computer. We could make better product decisions. So we recently had a conversation with BMW. They have a car. The car has usually, 15 or so thousand features. They ran this past their customers. The customer said, well, okay, 2,000 of these, they're not so good. Can you do a simulation then very quickly based on the revised features of the car, how the new car would look like? And so there are positive and negative things associated with quantum, or things where we need to be optimizing, or where we can be optimizing, and also things where we need to be thinking about protecting. And some of the forerunners in this field, so if you look at HSBC, if you're looking at JP Morgan, they are very, very heavily investing in both areas of quantum to keep their organization safe, but also to gain a competitive edge.
Yeah. If you see the quantum computer is very fast, is a probabilistic in nature, and is not like the way classical computer works, 0 and 1, is a predominantly fundamental three principles of wave particle duality, like superposition, entanglement, and interference. These three actually, if you see the sphere and all the points, you can assume exponential number of points. At any point, any kind of bits, you can classically link it with that, can be 0 or 1 in a sphere. It's called Bloch sphere. And problem is today is because quantum computers are not fully noise free, because of that, the moment you try to measure, it collapses. The new scientists are working today, they were able to capture the kind of state of these things, then that date will be noise free. But till today is not fully noise free quantum computers, because the moment I try to measure, the wave particle change the state of that things. That's the main challenge. But if you have huge number of qubits, and then you can manage it, then probability of getting the one will be much higher compared to other bits. That's how today is a hybrid architecture is evolving, and I believe future also next 10 to 15 years will be hybrid quantum architecture will be the next generation of way of computing and digital infrastructure.
Okay, so before we move on to the part where, okay, you scared me, what should we do? Does anybody have any questions on what was discussed so far?
Interesting subject, and obviously we're talking about largely the present and the future. But I keep thinking about the past as well. So obviously there's going to have been data leaks at some point in the past where you can't change what's happened, but in terms of managing that potential liability moving forward, in terms of the different types of data that may have been stolen, that could be PII, financial data, it could be IP data, it could relate to commercial products, it could be military products. I'm trying to think, what would you say the potential mitigations organisations could take to help continue to evaluate and mitigate the loss of previous data?
One way of looking at this maybe, so when we're working on these projects, is then many organizations, they don't have this data classification in place, so they don't know. And so a good exercise is usually to say, well, okay, well, if I didn't have that data, how much would it cost me? So to quantify, not just to qualify the risk, so if you have we have our normal risk matrix on a scale of 1 to 5, that's a qualitative assessment essentially, but if we quantify it, if we can say, well, if we didn't have access to that data, well, how much money would we lose per day, right? So that's one thing, so that the data register essentially and the data classification and valuation of that data, but then the same thing applies to our IT assets. So what kind of IT assets are we really relying on? Do we have a good CMDB? Many organizations don't have that. They may have done one in the past, but they don't have a current one. And then the same thing applies to that. So how much does it cost me if I lose a particular IT asset, an OT asset, or whatever it is, if I cannot perform certain operations in my business? And that is usually the starting point. So that's preemptive. That's good cyber hygiene, essentially. And if we have that, then we can move on to, doing other assessments, to going, okay, well, now we know what we have in terms of the data, how valuable the data is, what kind of IT assets we have. So what is actually the encryption we're using here? Are we just relying on the vendors? Yeah, they're going to be doing this, or do we need to put other safeguards in place? Another consideration is maybe if we look at legacy systems. So most organizations have legacy systems. Some, they don't want to change them, and they cannot change them. These systems, they were never built to have an upgrade in cryptography, for example. So if you find out what these systems are, then it buys you time to make maybe more reasonable decisions in terms of how you can protect the perimeter maybe around these systems.
And I mean, very good points for the present onwards, but I'm talking more about once the horse is bolted already type scenarios. So where data has been stolen in the past and where it's known, but maybe put under the carpet because, it's secured by RSA 1024, not a problem. We don't need to worry about it. But obviously those organisations probably aren't continually evaluating that risk over time based on what might come in future in terms of being able to decrypt that data. So I think it's more about what active mitigations, once the horse is bolted, should organisations look at?
I mean, once the information is out there, there's obviously you can't put the cat in the bag or wherever we're going with the quantum-based metaphors. But for me, it would be about that preparedness and that ability to react would come from your incident planning and data loss, significant data breach like that. As well, a lot of the time, I know you mentioned maybe the organisation would know about the information having gone missing, which I think overestimates the observability of a lot of large organisations. So in the meantime, having those plans, talking about having done the assessment of what your information is, conduct the assessments and the planning for what you would do if there was a breach, have the comms plan ready to go, conduct tabletop exercises to be able to rehearse what you might do and see, actually in reality, this probably wouldn't work as well as we'd hope.
I mean, another thing is, many organizations know who stole their data, even at government level. But the problem is, if you did something about it, some would class that as an act of war. So there is an issue. The very large organizations, they have offensive security teams. They're very good, maybe better than some of the hackers. The question is, can you legally go after them? Yeah, questions go both ways.
Yeah. So it's also important to, once you do assessment, then classification is important. What are sensitive data? What is the longevity of those sensitive data? Short term versus long term. And also assess your applications. Like fraud detection system will get higher priority than your CRM system. When you go for this crypto agility, you're going to think it. When crypto agility means how quickly you can replace your classical algorithm, cryptographic algorithm, the quantum-based algorithm, without minimal impact or very minimal impact. And agility is very important for your security, resilience, interoperability, and so regulatory compliance perspective. Like US national standards, they have come up with the 3 standards, like FI 203, 204, 205. Last year, they published it. And they're also suggesting few algorithms, like 4 algorithms, they're already now part of the standards. And algorithms predominantly for digital signatures and encryptions. And one more new algorithm they added recently, it is a lattice mathematical model-based algorithm, is a hash-based. So that can also think and how you can apply in your organization for PQC compliant. That's also important in that.
So I hear you say, like in every time in security, governance is key. You cannot control and defend and protect what you don't know about. Right, so it's like a first step across the board. This is not only about quantum. It's like know your APIs, know your application, know your networks, know your machines, you need to know what you have. So that's kind of the first step, I would say, before anything else. That's what I hear you say. Okay, great. What would be next? Like here you're talking about dual approach. Are we ready to do that already? Do we have the right algorithm, the support? To start today, let's say I want to do this today, what do I do?
See, there's 5P, I can say. 5P means don't panic, just acknowledge the problem is coming and accept it and be methodical. Second is prepare your inventory as detailed as possible, not only the breadth, also depth. And then to prioritize which applications, which algorithm, how you're going to do that, do some kind of POCs, learn from that, and then prioritize, prepare. Then progress slowly in that. So to do learn from one application, then take the things, then go for next applications, and try to become an enterprise scale, because scalability will be important going forward, because you cannot do, this is a transformation. This journey will take minimum 3 to 5 years to become fully compliant. And also suggest at the same time, lot of vendors are coming the PQC compliant. take the software bill of materials or cryptographic bill of materials from the vendors. Are they PQC compliant? How to be integrated in the system? How we are going to slowly build your applications? Are they interoperable in the future? That is most important aspects. I think we have to start ready because it's a journey. You cannot wait for the computers to be ready, then you can start journey. Then it will be too late for you to accept by the time your data will be available to publicly. So this is the right time to focus.
It is really dangerous when we implement these things. So the algorithms that you'll be familiar with, RSA, AES, these things have been tested over a long period of time, and there's a very good amount of consensus about them. And it's rarely the actual algorithm, which are designed by very intelligent people on blackboards usually. In my experience, it's the implementation of the cryptographic algorithms that are always the problem. I mean, I'm sure there are enough people here who remember quickly, everybody, let's move off SSL to TLS. Quickly, everybody, we need to get off 1.0 to 1.1, and now I'd be writing people up with critical findings if they had 1.1 in their organization. And I imagine we'll go through a similar journey with the post-quantum algorithms, the quantum-resistant algorithms that are being implemented as well. So completely agree, understand what you've got, prioritize, but be really hesitant to be the first adopter and to perhaps buy something off the shelf because it's time to renew the little widget that is in your location, and that's not going to support a new cipher suite. So we'll buy the one with the dilithium or whatever kyber crystals that are off the shelf, and then you're then stuck with that for the next 10 years, and somebody comes up with a vulnerability on day 2. So there are some huge trade-offs, and it's a risk-based approach.
What we see at the moment is that, our clients, they're not implementing PQC. But what is important is that the vendors, they have implemented PQC, and we're looking at the very large vendors. So the AWS, Microsoft, and these sort of guys, they have implemented this in their solutions, whichever it is. But then we also operate in different geographical regions where they don't have access to the SAPs and the Oracles of this world, where the software development process is a bit more like, we do a refresh of the technology, and then the accounting manager says, well, can you add a new column here? This sort of things are very hands-on. And so it is more like that we have to not just worry, but assess these suppliers in terms of, are you doing anything in terms of post-quantum? Are you having these PQC algorithms baked into your hardware? Is it in your software? Before we make the purchasing decision. And that is probably, if we're not a company that is developing its own hardware and its own software, where the truth for most organizations lies, especially SMEs, right? And that is, from an outcome perspective, usually something when we do a scanning exercise, so we have a cryptographic scanner, we run that across the organization. If ours cannot cover it, we partner with others to do it, and then you'll get a risk profile. And you will see, okay, these are the things we need to look at. Okay, is this delivered by a supplier? Is it Microsoft? Okay, Microsoft, we're not going to tell them do more post-quantum because they're doing it anyhow. But then are there other suppliers who need a bit more hand-holding? And so that is what I think can be done reasonably well. We've only had one organization approaching us because we also do quantum products through partners. And they said, forget about the risk assessment. Just send us the product specs. And then they came back to us, okay, maybe we need to do the risk assessment first.
So when you start this scanning, don't use manually. Use some tools already publicly available or some vendors available tools. That will really accelerate and will give you a lot of insights that you are not aware of that. Because the tool vendors, companies, they're spending a lot of time to what are the assets you have in the organization that you should be care going forward that. So that's one experience that we have got it. Instead of using some manual way of an assessment, use some tool-based or automation-based approach. Because a lot of tools coming with the machine learning capability as well. So machine learning and then adding the new features going forward. So these tools also will be evolved to various versions to be matured enough, but start with some automated tool that's already available with various vendors or specialized security assessment companies. That's
when you're going to discover you're still using SSL v3 instead of TLS in some places of the company.
So there wasn't a lot of engagement from the vendors, the Googles, etc. are they just waiting to see what bomb drops? What's the feeling from you guys?
From my perspective, these vendors are engaging, but I'm talking about smaller vendors. So the smaller vendors, so if you're looking at, let's say, I mean, I wouldn't worry about the large ones because they will be doing this. And the reason why they're doing this is because they supply to federal agencies. So if you work with federal agencies in the US and in Canada, for example, if you're not PQC compliant, you will not get any business from them. And so they will be doing it. But the smaller vendors, if you have, let's say, a custom solution built for your organization only, a small vendor, will they understand PQC? And do they understand the complexity of building PQC into their system? There's a very nice podcast. If you go to PQ Shield and listen to the one about Signal, the counterpart to WhatsApp, how they try to build in PQC into their solution. I worked on ERP systems. I always thought this is an open heart surgery. This is a different kind of thing. It's two at the same time. That's the level of pain, technological pain you go through when you do that. And so it's very complicated. But initiating this conversation with the vendors now protects you from a procurement perspective because you're going through a refresh cycle. Oh, we need new IT, we need new OT, whatever, new software, right? Now, when the procurement cycle comes around, you want to have had a chat with the vendor saying, listen, is this PQC solid or not? If not, we're not buying it today, right? But you need to have the conversation now because they also need time to transition. And that was my point.
Out of curiosity, would you call Palo Alto a smaller vendor or a larger vendor?
Say that, I didn't hear the question.
Would you call Palo Alto a smaller or larger vendor?
I'd call it a large vendor.
And WSO2? No, just kidding.
As I said, we are working. We have one of the top quantum physicists part of our team, so Dr. Frank Lehman, so we're working a lot on this. We're out of time, gentlemen. Thank you very much, everyone. I'm going to have to get to the next session. I hope this was useful. If you have more questions, you gentlemen are staying around until this afternoon. If you have more questions for them, don't hesitate to ask. Thank you very much for your attention.
Thank you.